Welcome to Shopbench. Today I thought we would take a look at putting together a kit that I'd picked up from one of my flicking through AliExpress looking for little mini projects to do. I was having a look for just some decorative projects, maybe something to put on a desk at home or at work, or just something with a bit of visual interest to it. That was just a simple, cheap kit that shouldn't take too long to put together, just to refine those soldering skills and just to have something visual and interesting to take away from the monotony at work, because who doesn't like a nice little bit of tat on the desk at work. So to that end, I ended up looking through and I picked out two different kits. There's a clock kit and an hourglass kit. Let's take a quick look at those. And this is the clock kit, and there's like a million of these on AliExpress, and I just kind of like the idea of a full dial clock that's displaying the time, just again something visually interesting. And then we have this one, which is an hourglass kit, which I haven't actually seen what it's supposed to do, but I would imagine it's going to look like the sand running down from one side to the other, filling up and then alternately filling back the other way, just to mimic an hourglass being uprooted and all the sand running down. I think I'm going to do the hourglass one today because I don't really want to get stuck into the clock, because I think the clock has an awful lot of components and I just really wanted a quickish build today. Looking at the kit, it looks fairly straightforward. We can see that there's obviously a big bunch of LEDs. There's a programming header, there's a microcontroller, there's a power jack, and a button, which I'm assuming that when you press the button will probably trigger the sand flowing from one side to the other. And then it looks like there's an on-off switch. I took a look at the microcontroller, and it is an 8051 derivative, although quite a fast one. It's 35 megahertz, which is faster than some of the 8051 microcontrollers that I have. So not sure of its full capabilities, but it looks like it's got kilobyte of program size, 256 bytes of RAM, 4K EEPROM, which is quite reasonable, and then 14 I/O pins, of which I'm assuming that will be controlling the rows of these LEDs at a guess. But we'll see what it looks like when it's in action. And luckily, it can be reprogrammed if necessary, because there is an ISP header on the actual circuit board. If we take a look here, we can see the header along the top here for the ISP and system programming is a TX, RX, ground, a VCC, so just simple serial programming. The board itself, we can see the two different sides to the hourglass where the LEDs will go, the power jack, the on-off switch. They have a footprint for USB power, although it did not come with the USB connector, so I will actually be using a mangled USB cable that I really didn't like the look of. It will serve its purpose. I'll just plug it into a USB power bank, and I will just solder the leads right onto the board for now. Ideally what I'll do is I'll get some kind of battery holder and put it on the back, and then wire up power that way, because it looks like you can power this from two AA batteries, because the data sheet said the voltage supply for the chip is 2.5 to 5.5 volts. So as long as we've got enough voltage to light the LEDs, we'll see whether we can just hook that up to a battery pack or not. Otherwise I'll think about maybe doing some other kind of power circuitry on there. So why don't we go ahead and get started and see what this looks like, and just crack on and put together a nice bit of visual interest for the desk at work. So looking at the board, we can see the orientation on the LEDs, and we can see the traditional schematic footprint, which shows a flattened side to the LED and a rounded side. Flattened side corresponding to the negative, the cathode of the LED, which is the shorter leg here. So first things first would be just to populate the board with the LEDs. I took a quick look earlier, and they would be the shortest of the components to put down first. Now I'm going to be brave and see if I can put all the LEDs in and then turn it over without them, hopefully, or at least put several in, turn it over without them all falling out, and then just solder some in place and then move on to the next row. If this gets too tedious and monotonous, you may find yourself speeding forward in time to the end of the LED soldering. Otherwise, I'm just going to go ahead and crack on here and put these LEDs in. Now, my plan will be to turn it over, tack solder one of the legs, straighten up the LED if necessary, and then solder the other one on. Previously, on my last project, which was a Christmas tree, I was using the technique of bending out the LED legs to hold them in place, and unfortunately that robbed me of the opportunity of correcting a mistake because I couldn't desolder an LED. With the bent legs, there was no way to apply heat to it to remove the LED without damaging the LED. It was getting overheated because it was just taking far too long to actually heat up and then try to desolder. And so I had to use alternative methods. Ended up having to snip that LED out of the circuit and then just totally replace it with a bit of a bodge, a bit of a hack, but it did the job. And again, it was just a quick project, so it wasn't necessary for it to be a phenomenally soldered job. It just needed to be enough to put it together, and that was our office area Christmas tree for the holidays for about 3 days, and then we were all off work for a week. So right now I'm just going through and tack soldering on each of these legs just to hold them in place. And I'm going to imagine when I flip this over, they're going to be all over the place. I see, like that one there is just totally proud of the board now, but if I just apply pressure with my thumb and then reheat that, I can seat that down flush. And again, I'll just go through and apply pressure to each of them, reheat the leg quickly, straighten up the LED. A little bit too eager there, didn't keep it held long enough for the solder to actually finish setting. And again there we go. There we go. That's all one side tack soldered in now, so I'll just whip through now quickly and finish up the other leg. Now, given that these are LEDs, I'm trying to apply the heat for as little time as possible, as I don't want to damage them. LEDs being particularly heat sensitive devices, it's very easy to cause damage to the component through overheating. So there we go, that's the longest leg on the first side. Looks like the longest point is what, 7. So 7 down to 1 with one middle piece, and then again 1 up to 7. So row 1 done, let's have a go at row 2. We'll get these in place. I don't even know what colour these LEDs are going to be, so it's going to be a complete surprise to me when it actually fires up. Now, one thing that I did do before I started today is the microcontroller chip and the socket, because it was amazingly packed in this sturdy plastic bag. The pins on both the sockets and the chip itself were just all bent out of shape, so I had to very carefully take some needle nose pliers and just gently tease the legs back into shape and then straighten them out again, ready for inserting the chip into the socket. So that's row 2. It's going to get a bit more difficult to work around now. I could at this point stop, maybe trim the leads after the first row, but I don't think I'll have to because they're offset, so I can get the soldering iron in and the solder in from the opposite side without any particular interference. Just using a chisel tip today. There we go, that's this row soldered up there. And that row is actually not looking too bad. They're looking straight, they're not looking proud. Maybe that last one there is a little bit skewed. Speed that one up. And this one here is not looking so great. As you press them onto the board, the LED will sit flat to the board, so it just kind of snaps square very easily. Just like that. There we go. That's that row done. Go through here and put this next row in. Now it would be interesting to see what the source code for this looks like. I may actually take a look, Google around, see if anybody has the actual source code for it. With it being 8051, it's going to be just some standalone C files or maybe even assembler files, who knows. I've seen both. It's certainly not going to come as a nice sketch in an IDE such as Arduino or anything like that. It's going to be some fairly raw looking files from somewhere. I think maybe could have clipped those leads at this point. See if I can still get this in here. I'd rather just snip all the leads all at once than stop now and do them all one at a time. Just trying to just keep it rolling, keep the soldering iron working so I can turn it off sooner. There we go. So those are all tacked in. Again, they're not looking so bad. Just quickly whip through. I think I will snip them all down before I do the next couple of rows. Because it is starting to interfere just a little bit. Again, just trying to heat the component up as little as possible. Yeah, there we go. I think I will now briefly get the snippers and just trim those down. Did I can do the legs on that second row. I'll trim down the outer legs and then I'll do those. Snips. Good job there. Solder flowed nicely through the plated through holes a little bit. Got a little bit close to the board on that one there. Snip this down, these two down a little bit. Standing proud compared to the rest. There we go. Snip these ones. I think I have another couple of projects, just simple DIY kit projects on the way. Can't remember all of the things I've ordered on that particular shopping spree. When you're only looking at, you know, $1 to $2 delivered, you know, it's, why not? You know, grab a couple while you're at it. It's, again, it's just a bit of interest. Gives yourself a reason to put something together. Keep working those skills. Now, with this being an 8051 controller with a programming header, assuming we can find source code for the default implementation, it wouldn't be too difficult to alter it to do maybe some more patterns. So a customization project, a software project follow-up potentially. And the chip is socketed, so it is possible to maybe even replace this particular microcontroller with something else if we find that what we want to do doesn't fit within the constraints of the chip itself, because it is the main limiting factor is the amount of RAM that it has. It only has 256 bytes of RAM, which isn't a lot to do anything sophisticated. It's literally just going to be enough to do a few basic patterns, although you can get quite a lot out of quite a little when you put your mind to it. There we go. 3 rows down. The nice thing about these projects is they don't take an enormous amount of time to do. It's just maybe an hour or so. I'm hoping it'll be less than an hour. Don't want to be sat here fiddling with LEDs for more than an hour. But at least not on this project. There we go. So this makes absolutely thrilling viewing. Doesn't look so bad. Mindfully practicing feeding the soldering from the far side, letting the soldering iron heat up both the component leg and the pad to try and get optimal wetting. Don't really want to have to debug any kind of a solder joint problem with them later. There's something about LEDs that flash either in a nice pattern or an unexpected way that just draws the attention. Quite like looking at lights, especially ones that are arranged in a geometric pattern and then respond in some kind of programmed way. Especially if they have that surprise factor where you're not sure there's some kind of pseudo-random behavior to them. These, I imagine, are probably quite straightforward. I mean, if I had to guess, I would imagine it's just going to look like they're just going to fill up and fall right down here, although we'll see if they do anything. I'm going to get, well, if you look at the, as you see on the circuit traces, which ones are wired together. Yeah, maybe have to see if I can find a schematic for that at some point and take a closer look at how it actually is wired up. Today's mission is just to get this thing soldered and working. Justify my massively outrageous spending of $2. Quite good. So far I've been quite fortunate that these legs haven't been pink enough and taken out an eye, as is usually the case whenever I'm cutting leads off components and I have not got a sure grip on one of the ends. Put these 3 center ones in. Feeling I did not follow my didn't follow my pattern of previously of only doing the one leg. I got all carried away and did both legs, but luckily the solder stays molten just long enough for you to heat up one leg, heat up the other leg, and then press down, and there we go. It's those 3. Alright, we're over halfway there on the LEDs. I have a couple of other LED projects coming up. Animated sign that I want to make, inspired by a Big Clive project that he showed us with his arcade animated sign, which I really want one of them, and I'm planning on making a couple as gifts, just to spell out some choice phrases for them, appropriate phrases I should say, because you can spell out whatever you want to really when you've got 100 LEDs. That will be on a future video when I get a little bit further along. The design of that one is to use shift registers and LEDs themselves with some appropriate current driving technique to try and introduce animation with the shift registers rather than resorting right to a microcontroller, which could definitely do, pull out the big guns and use a microcontroller, maybe with a port expander to turn on the different LED sections. But I wanted to try and do something with some discrete chips, as that's what the original project was using. It's just using the several shift registers clocked by a 555 timer. That's something I have an interest in, just soldering up and seeing how that works, because the natural inclination now with MCU boards being so cheap is just to throw a nano at anything. You're only paying $3 for it, why not? That's practically giving them away. Even STM boards are $2 to $3, which is insane given the capabilities. But the purpose of the chasing LED sign projects is more to go back to when you have less resources and finding a way to implement things with less. Ooh, that one didn't reseat very nicely. There we go. There we go. I think I was pressing it at an angle. That one was not being cooperative. Break off another bit of solder. Get this row of pins in. Alright, we're getting there. Almost over the hump of the soldering on this one. Hopefully all these LEDs will work. I've not tested them all out. Just thought I would leave it as a complete surprise. That, and I don't have a good rig to test out this volume of LEDs ahead of time with any kind of speed, and that's something I'm going to have to make for myself. Would be some kind of test jig to quickly plop LEDs into to get a quick register on whether or not they are indeed functional. There's nothing will ruin your day more than soldering in 200 LEDs and then finding out 5 of them not working. How are they looking? That's looking straight. It's not too bad. See them all lining up nicely. Yeah, coming along. Next, roll. Long leg, short leg. I'm sure I must have put one of these in backwards by now and people have cringed and spotted it like 5 minutes ago, and I'll have been merrily soldering these in, and then we'll find out later that one of them's backwards. We shall see. At least this particular project isn't all surface mount. I'm trying to decide whether that would be better or worse. I mean, it comes with its own set of challenges, but I just started to experiment a little bit with hotter reflow soldering, which I'll certainly show you on when we do a look at the Mr. project. I had several boards, companion boards to the actual base unit that you need to be able to run the Mr. project, and that was a lot of surface mount components, and you could definitely solder them by hand if you take enough time, but there were so many components that I didn't, and the spacing was quite tight on them too, that I didn't really feel comfortable soldering so many small 0604s sizes, I think they were, together. I thought, well, now was a perfect opportunity to learn how to do a little bit of hotter reflow soldering, and I can see why people will immediately do their best to get their hands on some kind of reflow oven, because for a first time, I think I was doing everything, I wouldn't say wrong, but because I would say at least half wrong. It was interesting learning how big of a size of solder paste you needed to put onto each of the pads for it to make good contact. The first thing I was putting on too little, and then I had the wrong shaped blower. I've got one LED that needs straightening up there. I had the wrong shaped nozzle on my rework station that was causing basically too much air pressure to come out all at once. It was too narrow a bore, and as soon as the solder paste started to go molten, it was interesting. It was almost like a liquid. It turned liquid, but not liquid metal with stickiness. It was almost more like imagining water coming out of a sponge or whatever chemical composition they have on those solder pastes, where the chip would start to float on top of it, and nothing was holding it in place. So as soon as I pointed the nozzle towards any chip, it just wanted to blow all over the place, and I ended up with things turned halfway around. One or two things were blown completely off the board, having to try and hold one side with some needle-nosed tweezers. It was a nightmare. I was like, okay, this is definitely how not to do this. So then I looked through the nozzle set for it and went with a wider bore, because that was because I had the air was coming out the slowest that the rework station would actually blow out. So it wasn't that I'd gone all crazy with the air pressure coming out of the reflow station, the hot air station. There was literally wasn't a lower setting to put it on. So the only variable I could control then was the bore on the nozzle. So I went and looked for a bigger bore on the nozzle, and that made life considerably easier at that point. And to the point where I think, well, I need an even bigger one. It was still a challenge. I was still having to try and anchor down the component with tweezers to keep it somewhat in place. It certainly wasn't blowing all over the board anymore, but it wasn't sitting in place. Now, of course, all of that goes away with a reflow oven, so I would definitely be looking to get a toaster oven and some form of reflow controller. Tempted to just buy a reflow controller, because there's a lot that you can get hold of, and they're not super expensive, but it's kind of one of those learning opportunities where I would rather make one and experiment with it for the sake of actually doing it myself, rather than get a unit. But at the same token, that will put back when I'll have that capability for longer, because you know these projects go, you get the idea, you start on it, and then something pops up, and then sometimes it'll get shelved for a while, and that's me not having a reflow oven. I did look at maybe picking up one of the cheap IR ovens, but in honesty, it looked like so much work that you have to put into it to customize it to make it usable, that I'm not convinced that it was amazingly better than just a toaster oven. I mean, it's supposed to be a more even flow and more even heating, but I wouldn't say horror stories, but the war stories that people have to go through, like replacing tape because it's the wrong kind of tape, is holding some components together inside, and it scorches and smells when you heat the oven up, so you got to go and retrofit a whole bunch of Captain tape in different places, etc., etc. Which, that's a project itself. It's the wrong project at that point. I think it's much more satisfying if you're doing all that work and it's pseudo your own design rather than pseudo fixing somebody else's bad implementation. Although the price point might be there for it, and in a perfect world it would be a really good even heating with the IR, which is definitely going to be better than a ceramic heating element, because far more of that heat transfer is going to be straight radiation and not radiation with a combination of convection and then blowing it around to try and avoid hot spots. But we will see where that takes us. Right now I don't have any more circuit boards that require surface mount. I am planning on learning KiCad and designing a couple of my own, at which point I would like to use surface mount components because they are smaller and to a degree cheaper. But I may end up just doing a combination of both surface mount projects and through hole. just in case anybody else wants to have a crack at them and they don't want to do surface mount. A nice through-hole board, looks lovely too. I mean, there's definitely something aesthetically pleasing about seeing rows of nice components all evenly laid out, all your resistors, capacitors. They just look nice. I think they look a little bit more romantic than, say, a flat board of just surface mount. They don't look as neat, but they certainly look more interesting. So it might depend on what the project is. If it needs to be low profile and fit inside something, surface mount's going to be the obvious choice. If it's going to be an interest piece or aesthetically pleasing, a combo of through hole and maybe some surface mount, especially if there's any kind of ICs or voltage regulators involved, as those are quite bulky components for through hole. The end is in sight with these LEDs. Almost there. We're looking at last two. Looks like we've got two spare. There we go. 1, 2. IC has been programmed nicely, because it would be an absolute shame to get this far, finish the components off and then find out that there was something wrong with the chip. Not keen on how those LEDs were sat. There we go. That looks nice now. Alright, let's trim these up. I think we will do the IC socket next. Alright, with the IC socket, we'll line up the U-shape here, the dimple, with the marking on the actual board itself. That will focus. It's right there at that end. See if I manage to straighten these legs up. Oh, there we go. The opposite corners approach. Just going to tack solder in one corner here, its opposite corner. Take a look, see if we're sat flush, which actually sticking up just a little bit there, if you can see. I'm going to go ahead, heat that leg up, push it flat. That leg up, push it flat. There we go. That is, it's just slightly twisted on the body. There. And that's as flat as it's going to get. Alright, let's whip through these. It's nice that it actually came with the socket, because you can actually swap it out for, what is it, 14 pin, 1, 2, 3, 4, 5, 6, 7, 8, 16 pin IC, so I'm sure there are other 16 pin variants of microcontrollers, especially 8 or 5 ones, that we could use to replace if they are pin compatible. So if this is all a non-starter, I may take a look and see what I have in my microcontroller box. I think I have some C89C 205 ones. Don't recall how many pins they are. Alright, set that down. What next? this push button. Alright, push button. I don't know about anybody else, but I quite, there we go. I often get grief from those push buttons. I always end up bending the legs all over the place. I do not have Big Clive's fingers of steel, so I can't solder quite as far down the solder nubs as he can, so I'm just gonna get some new. Button down. I think this switch is probably the next lowest profile. I wonder what they're using for current limiting, because there's no resistors part of this kit. It did come with an extra capacitor, and there's no footprint on the board or markings on the silk screen for a capacitor. If anywhere, would probably be decoupling across the power supply. But there is no footprint on the board for said capacitor. So I guess I just have a spare. There's that switch. It's looking okay. And with this DC barrel jack, I don't have a DC power supply with a fine enough pitch connector on the end of it, so that's why I hacked together that USB cable. And as I said, I'm just going to solder directly onto the board. Alright, I thought that was bent for a second. Wasn't quite flush. Last thing last, let's get this ISP header in. Let's get the one corner pin in first. And what we'll do is we'll lift the top flat. Too eager. There we go. Should have just whipped down these 3 pins here. 1, 2, 3. There we go. Right, power leads. Just going to tin these 2 pads here, which is where the USB inputs would be. Now, this DC jack is center positive, so that will mean we're going to want the positive lead coming in off this pin here. I don't know if you can see that trace here that comes from the center, positive, and then this bit here is a negative that goes to the switch on that side. Trace here on the back, we can see this pin here is the positive. Get our cable. Already tinned the ends on the cable, so you just need to reflow the pad and the cable together. Well, that didn't work out so great. There we go. It's quite an awkward angle to try and solder this into. That's the one. Should be fine. And then finally, put the IC in. Remember to line up the dimple on the IC itself with the dimple on the socket. So I already had to go ahead and straighten these pins anyway, so good to fit right in there. There we go. That is now together. Actually doesn't look too bad. Let's try moment of truth. So that's off. Let's get my power supply for the day. Put that in. Moment of truth. Nothing. Well, I was definitely getting 5 volts out of this earlier. That chip's getting hot. Well, I think at this point I may have to pause and figure out what is wrong. Well, we've discovered the source of the problem there. I mistraced where this was, so the center positive actually comes out at the back here. It's this pin here, so I needed to attach the positive line here and the negative to the middle. The clue being that the chip was getting extremely hot very quickly, and now it actually does work, although I have a couple of LEDs that are not lighting at this point. So it seems like this one here, and then the button actually controls the speed. So we can fill it up on quicker, so it gradually falls down, and it always seems to fill from one side to the other. So if it was mounted upwards like this, it's always going to look like it's flowing down. So we can see I think that's this LED here, so 1, 2, 3. They're not quite working, so I think I will take a look at those and see whether it's the LED or whether I got them in backwards, as I fear. It's possible. Otherwise I've got 2 replacements. I may have some clear blue, but otherwise yeah, looks alright. Doesn't look too bad. Not too terribly unhappy with that. It's very bright when you see it in person. It's very bright. It's kind of washed out a little bit on the view there, but it actually looks very nice. That's going to look nice on my cube wall. Well, thank you for watching along with me putting this project together. Hope it was more entertaining for you than doing nothing. Hopefully I'll catch you another time. There'll be lots more projects in the future. Have a good one.